Hi, welcome to another Unity from Scratch tutorial for beginners. In this tutorial, we're going to continue looking at the conditional statements that we looked at in the last tutorial, but this time we're going to make them a little bit more complex, and we're also going to make them into a little bit of a logic game. So I've created a simple scene just here, which has a door, and this door is its own game object, so we can move that door like that. The objective of our little game we're going to be creating is to turn these lamps on in the right sequence to open up the door, or in this case just get rid of the door altogether. So the first step we have to make is to get these lamps that I've got on the wall here to have a light in them so we can turn them on and off. Now if you want to make this scene yourself, I grabbed a lot of these assets from an asset set called Decrepit Dungeon Light, and I also found a whole bunch of retro lamps. If you type lamps into here, you'll find these retro lamps that you can also have for free and put them into your scene. Now you don't need them, of course. You could just have a plane that represents the door and two objects that we can click on that represent these two lamps. Okay, so the first thing we're going to do is add some lights into our lamps so that we can see when they're turned on or off. The reason behind using lamps is that back when I spoke about variables and then we went into conditional statements, we talked about how bits represented 0 or 1 values, or on and off values, and they're the same values that are used in conditional statements. So 0 or off also relates to the logic value false, and a 1 or an on represents the logic value true. And so these will help you visualize what's going on with these logic statements. Right, so I'm going to select the first lamp, and in the hierarchy just right click on it and add a light to it. So find light and go to point light. Now by selecting it in the hierarchy and doing that, it will actually make the point light a child of the lamp. And now we can see that we've got this light. Just move it out from the wall, and I can move it up and just sort of sit it inside of that lamp. Now, by default, the shadows won't be turned on. So if you want to turn the shadows on for that light, if you just select the light and have a look in the inspector and go down to shadow type, you can change that to hard shadows, and that will give you shadows from that light. I've already got some light in this scene coming from the lamp that I've put here, because without it you wouldn't be able to see anything. Now this light is currently turned on, and I'm going to just select it and Control D to create a duplicate, and then drag and drop that duplicate onto the other lamp. And now all we do over in the scene is just drag that other light straight across, and it will already have its shadows and everything turned on for us. So it's just a matter of positioning it and making sure that it's attached to our other lamp. Alright, so now we have two lamps that we can turn on and off. So the next step is to create a little bit of code that will allow us to do that. Let's create in the project a new C# file, and let's call it turn on light, and double click on it to open it up. Okay, now in order to turn the lights on and off, we need to know about those lights that are attached to the lamps. So we will put this code onto the lamps themselves. So we want to create a public game object light, and that'll allow us to pass the light through to this code in the inspector. Now we don't need any of the other code that's in here, so we can delete that and just leaving these brackets around the whole class. The function we're going to use is called onMouseDown, and it will register when we click on an object that has a collider. So void onMouseDown with nothing in the brackets, and then two squiggly brackets. And inside of this, we will go light.setActive. Oh, true. So the set active, what that does is make the game object active. So I'm just going to save this and go back into Unity and show you what this line of code will do. Set active. So if we select any object, I'm just going to select this light here. When you run a set active, what it does is it just ticks and unticks that box basically. So it turns the game object on or off. And by doing that on a light, it turns the light on and off. So our code is performing a set active equals true, which means that we'll want these lights to be initially off when we run our game. So just select each light and turn it off. Now, it's very important that the objects that you attach the code to have colliders. Now, in this case, my lamps have a mesh collider on it, so that's fine. If you're using something else, say you've got like a cube and you've put the light on top of it, make sure the cube has a collider on it, which it will by default if it's a default cube that you create in Unity in this way. Okay, so the next thing to do is grab our turn on light code and drag and drop it onto the lamps, not the light. And we'll put the same code on both lamps. Now, if you have a look at the lamp in the inspector, you'll see there's an exposed variable where we can put our light. So point light on lamp 2 is going to go into the light slot for that one. And the other lamp, we want the point light for that to go into that slot there. All right, so let's run this and see what happens. When we click on those lamps, the colliders will register that we've clicked and it will set active light to true. Okay, and actually if we select that light, you can see the boxes off here and you'll see it get ticked when I click on here. There you go. And the same thing will happen to the other one as well. Click on there and the light comes on. And so it's an active object. Now, all that code is doing is setting the active to be true. So it doesn't matter how many times I click, it's not going to make any difference. If I turn the light off and then click it again, it'll turn it back on again because I'm forcing it off. But what we want the code to do is if it's on, turn it off, and if it's off, turn it on. Okay, now the code to do that is not as complex as you think. Let's go back into here. So we want to set the active state of the light to the opposite of what it already is. Now, what it already is can be found in the value light.activeSelf. So when the light is turned on, ActiveSelf is true. When the light is turned off, ActiveSelf is false. Now, we don't want to set the light to what it already is. We want to set it to the opposite. And the way we do that is we use an exclamation mark at the front. And this exclamation mark means not. So set active to not what it is. And it's going to switch it the other way. So if it's true, it will set it to false. If it's false, it will set it to true. So let's save this and have a go. Right, so now when we run, and we can click on our lamps and turn them on and off like that. Okay, so we're going to use these like little switches in a sort of mini puzzle where we can learn about logic and combining logic statements so that whenever these lamps are in a certain on state or off state, we can get this door to disappear and open. So to do that, we need a new little program. So let's create a new C# file and let's call it door open. And in the hierarchy, create a new empty object, and we will call this our door puzzle. Okay, now drag and drop your door open onto the door puzzle object so that when you click on it, you'll be able to see that the script is attached. Now, the script needs to know about our two lights, and it needs to know about the door because it's going to make the door disappear based on the sequence that these lights are on. So let's open up our code, which will be our default code, and at the top we'll make some exposed variables to grab hold of those lights. So we want public game object door, and we want public game object let's say light 1, and public game object light 2. Okay, save that. And let's just switch back to Unity. Select the door puzzle object, and you'll see there's an exposed variable for door light 1 and light 2. So we want to drag the door into the door position. Then we're going to grab light 1 and put it into the first slot, and light 2 and grab it into the second spot. Now I've actually mixed those around the other way. It doesn't matter for what I'm showing you. If you're going to be particular about the actual order that these get turned on, then you will have to take notice of where you've put them. But this particular code won't do that. Now, just before we get into the door opening code, I'm getting a warning down the bottom that keeps popping up because what I've done in the turn on light code is I've used the word light as a variable name, and light is actually the name of an object, a lighting object in Unity. So I'm sort of using it where I shouldn't be using it. So I'm just going to change this in here so that warning goes away. It'll still work, but it's probably not a good practice. So I change that to my light, and change it down here to my light, and over here to my light, and save that, and that should get rid of that warning. Yep, okay. Since we've changed the code, we may also need to just check that the variables are still set in the exposed my light value, and as you can see they haven't been, so we need to just reassign these lights again so we don't get any errors down the track. Okay, so just drag and drop the correct lights for each lamp onto their position in the script to fix that problem. Alright, so let's go to our door open code. So what we want is for this door to disappear when both of these lights are turned on. And to do that, we need to use the logical AND operator. Now, the AND operator works when both things on either side of it are true. So the statement that you write is like this: if we have light 1 dot active self and light 2 dot active self. Remember, active self will give you true or false value. Now, an AND statement will be true when both things on either side are true. If one is false and one is true, it won't trigger this. Okay, so when both of these things are true, we want that door to disappear. So let's go door.setActive false, like that. Now, in the case that one of these is true and the other one is false, or they're both false, we want the door to come back again. So else door.setActive true. So in every other case, the door's going to come back. Let's save it and give it a go. So switch back to Unity and press run. And let's try it out. So if we can click this as on and off, nothing happens. We can click this one on and off, nothing happens. But if we click both of them on, the door disappears. So the door is now open. If we turn either one of them off, the door will come back. So you can see that the only time that that AND statement fires or produces a true result is when both sides of the AND statement are true. And that's the way that the AND statement works. So how do you know what you're going to get when you start combining values with an AND? Well, you can look them up in what's called a truth table. So in logic, we have these sets of tables for different types of logic operators. And this one here you can see is the AND logic table, our truth table. So here we've got two inputs, one called P and one called Q, and you can think of these as the two lamps. When they're both on or when they're both true, then the result is true. When one is true and one is false, you get a false. When one is false and the other one is true, you get a false. And when both are false, you also get a false. So that's the truth table for and that's what we can see currently in the running of this program, which is very nicely illustrated down here. And the and symbol in code is a double ampersand sign like this. All right, so that is the and symbol. Now, another really common logic operator is the OR. And OR is two pipes that look like that. And you'll find them on your keyboard if you do a shift and then the key that's usually above enter or return. Okay, so it's a vertical looking pipe. On my keyboard, it's below the delete key and above the return key, but it's over that side anyway. Okay, so now we're going to try it with an OR, and we're going to say light 1 is on or light 2 is on, then we're going to get rid of the door. Otherwise, we're going to bring the door back again. So I'm going to save this and let's just have a little play, see if we can figure out exactly what's going to happen or what the truth table looks like. All right, so if I click this light, the door disappears. If I click it off, so they're both off, the door comes back. If I click this on, the door disappears. Okay, so it seems that I only need one of them on for the door to disappear. Now, what happens if both of them are on? The door still seems disappeared. So the only situation that we're getting a false in this statement for OR is when both lights are giving us a false signal. And that's exactly what you find in the truth table for an OR. Here's the logic table for an OR. And you can see very clearly that it's giving us the same results that our lamps did. So the door will disappear when both are on, both are true, or when just one of them is on. The only time that we will get a false value from an OR statement is when both of those lamps are false or both conditions are false. Okay, so that's the end of this quick explanation of the and the or in the logic conditions. There are many others, but the ones that you use the most in programming for games is an and an or. The not that we used also for turning the lamps to the opposite state, the not itself is also part of logic statements, which we might use a little bit further down the track. Right, so that's the end of this tutorial and showing you how to create more complex logic statements. I hope that made sense for you and that you embrace logic, because it's a very powerful concept and it really does make your code quite dynamic when you can change what it's doing at different times. All right, so thank you for listening and I'll talk to you again soon.